As we've been looking at the particulars of Hive, we should really discuss who and why you might use it as opposed to some other method of getting information about your data from your Hadoop cluster. The number one reason I see people using Hive is they have a background in ANSI SQL. Most commonly, the community that enjoys Hive and finds it to be very useful and productive is the analyst community. They are generally very advanced ANSI SQL users and often also are using Excel very frequently. What they are not is they are generally not object-oriented programmers. Object-oriented programmers usually prefer to use a more low-level MapReduce kind of an algorithm with Java or some other OOP language. Again, if you know ANSI SQL, HQL is going to feel familiar. Just heed my caution from practical experience, which is to research the differences before you start running HQL queries on your cluster. Hive is useful for asking analytical style questions, questions you would ask with ANSI SQL. So selecting information, sorting information, doing basic aggregations for information, so summing, averaging, min, max, those kinds of questions. It's not as useful for data cleansing. So what does data cleansing mean? Data cleansing means parsing, formatting, processing, stripping out white space, those kinds of processes. They can be done, but as you'll see in the upcoming example, it's a little bit cumbersome because that wasn't really the purpose of the SQL ANSI language originally. For that, you'd probably rather use either the lower level languages, so MapReduce, or what I'll be showing in subsequent movies, a different abstraction language, Pig, which was developed at Yahoo just for that kind of work, which is also called ETL, or extract, transform, and load work. And again, I know I've said this over and over, but I've seen this so often, this confusion. It's really an important part of the education around the use of Hive. Hive gives you the convenience of a SQL-like language, but it does produce MapReduce batch jobs. So if you're wanting or needing to have a more interactive type SQL access to your HDFS data, then Hive is not the particular library that you want to use. I generally will use Impala for Cloudera, and there are some other newer ones that we'll be talking about near the end of this course. Another reminder when working with Hive out of practical experience is, although you can do joins, the kind of joins that we're used to in the relational database world, so an inner join, an outer join, left-right join, so on and so forth, Hive is producing MapReduce jobs, and the overhead that can be caused by joining these tables that are only lightly related, because remember, HDFS data or even HBase tables have no need to be normalized or have formal relationships between the data in the tables. So what that means practically is if you're trying to force a relation from one table to another, most commonly all the data in all the tables has to be scanned or read possibly more than one time. So joins can be very, very resource intensive in a Hadoop environment. So you're going to want to test them and also really evaluate the execution of those types of processes in production level loads. So when we are working to understand the different libraries, we use WordCount. And so we're going to take a look at WordCount, which we saw in previous movies implemented with MapReduce, implemented via Hive. We're going to start with pseudocode. The process would start by you creating an HBase table for your text input, and then you would load your data into that table, and you could load it from HDFS, or you could load it from some other source, your file system, or if you're on the cloud, S3 or something. And then with your Hive statement, you would create a new destination table, and that table would be loaded with the processed results. So the processed results would be processed via a nested select statement, which I'll show you in the next slide here. So this is a partial example. This is kind of the center of that example. So you create the table, and you create it with two columns, word and count. And then you're going to create it from select explode, split, lowercase, regular expression replace, regex, for the line, and the punct and the control split the words. And you can see they're splitting on spaces here, so it's not a very sophisticated regular expression. You would probably have some errors, and you'd have to write a longer regular expression. And this really is kind of the guts of this, the regular expression, which they always say regular expressions are easy to write and not easy to read. which does cause them to be not as usable as some other mechanisms for processing. And you split as word from my input. My input would be the original table. And then you're going to group it by word, and that's going to give you your aggregate because you're going to add up the number of occurrences of a particular word. And then you're going to order it by count. So put the count of the words in order, descending, and the word ascending. So the tricky part of this, I think, is the regex. And it really kind of shows that Hive is not necessarily the right language to use for this kind of a problem. This is a parsing problem that we're doing here. And as we covered in earlier movies, this is done with OOP code in a more sort of natural way. And as we'll see in subsequent movies, it can be done with a higher level language, again, in a more natural way with the pig language. So even though I showed word count, I generally wouldn't use Hive to execute a word count. If that was the only language I knew, possibly. Rather, I would use Hive to retrieve the results out of an H-based table and possibly do some aggregation on it. So some counting, averaging, min, max, that kind of thing. Now, there certainly can be more complex Hive queries, and it really depends on your particular business situation. But I really like to use the best library, the library that was designed for the appropriate type of business task.